Quiet on the set. Hubble Space Telescope servicing mission 2, take 129. Hello, I'm John Grunsfeld, NASA astronaut.
Hello, I'm Russ Werneth. I was the EVA manager for Hubble Space Telescope servicing missions.
And extravehicular activity, or EVA, is a long way of saying spacewalk. And I had the pleasure of doing 8 spacewalks on the Hubble Space Telescope. That's why I'm wearing these spacewalking gloves.
We noticed that.
And of course in space it's a vacuum, so I had to wear a spacesuit so that I had oxygen to breathe, and these gloves. Now the spacesuit was pressurized to about 1/3 of the atmosphere's pressure from Earth, 4.2 psi, and that means that I was like in a balloon, and that balloon being pressurized means it was hard to move. So it made tools hard to use too.
So we had to consider that when we were engineering the tools used by the astronauts. They had to be unique tools, and that's one of the requirements, that it work with the suit with those gloves.
Yep. Now in 1997, a team of astronauts went up to the Hubble Space Telescope on the servicing mission 2. And on that mission, they used the features of the Hubble Space Telescope, things like doors that open and close, and instruments that can be removed using the suit to pull the instruments out, but you had to unbolt them first. Now they put in 2 new scientific instruments, and these are the super-duper cameras that allow us to observe the universe, but they needed those special tools.
So we built what we call the pistol grip tool, and you can see by the ergonomics of it that it is easy to hold, although it does have a battery down here. It doesn't weigh anything in space, but it has some mass to it. And the advantage of this particular tool is it has a computer chip inside, so everything the astronauts did in removing or inserting fasteners, we had recorded the number of turns, the direction, the torque. So we knew exactly what was used when that fastener was put in or taken out. And that helped us in future missions.
Yep. Now this tool was designed so that it could be used with a gloved hand in a spacesuit, a big paddle so that when you pull the paddle, it pulls the trigger to run the tool. It can run counterclockwise. You can switch it to clockwise. It runs at different speeds too. This was really slow. And you could program the torque for the tool, how much it turns or tightens. And all of that was very important. But there's one characteristic of this tool that's, I think, really unique. It was flown for the first time on that second servicing mission. Now virtually every mission in space uses this tool when they're doing spacewalks. But who designed this tool?
Well, the primary designer here at Goddard Space Flight Center was Paul Richards. And Paul actually did something quite neat. He later became an astronaut and flew on STS-102 to space station, and he used the tool that he developed here on the ground that we started using for HST and is also used by International Space Station.
Yep. Virtually every spacewalk carries a tool like this. I think one of the things that makes humans unique, and certainly one of the things that makes it a lot of fun to work on spacewalks, is developing tools. You know, there are other animals that use tools, but nobody in the animal kingdom ever came up with anything like this. Thanks for the great tool, Russ.
Thanks for using the great tool, John. And we have to tell you what EVA means.
You didn't say EVA.
Yeah, you got to say it first.
I didn't say it?
No.
What did I say? I wasn't listening, but...
Servicing missions. No, he didn't say EVA.
Well, we thought a couple of terms that they use all the time on home improvement would be a best description of what we've done to the Hubble Space Telescope. And what we've accomplished is that we've rewired it, and we've added